now is to talk about the maximum likelihood estimation. The idea is that we have a distribution and we want to find the values for the parameter of the distribution that makes the observed data most probable. You can see here we are taking independent observation. We are using the Bernoulli distribution, which you can see how it looks here. And we have a parameter, which is the unknown parameter P, which is the probability for something. We have observation xi. We have 10 trials, so we have 10 results, 0 and 1. Each result can be 0 or 1. And we are looking for what is the probability for a observation to be 1. This is the p probability. And we want to use this observation data and this distribution to see what is the most likely value for the p-value. What is the probability in our data? Based on that we have observed data, that what is the most likely to be the parameter we are looking for, p. Okay, so we have this observed data, and this is the formula for the Bernoulli distribution. So we have p 6 times, and we have, because we have 6 times the number 1 in our observed data, and we have 1, 2, 3, 4 times the 0, the opposite option. So we have p to the 6 and 1 minus p to the 4th, because we have 6 times the 1 value. Okay, so now we want to look for what is the most probable value for p based on the observed data and the Bernoulli distribution. We start by taking the log of this distribution, because it will be easier to take the derivative of. So we're taking the ln of this, and ln of p to the 6 is, you can take the 6 down here, and you can take in ln of this, you can take it down, and ln or log of multiplication of functions is the log of each function sum of this. Okay, so we have this result. We have 6 ln of p plus 4 ln of 1 minus p. Now we are looking for an extreme point, so we need to take a derivative and equal it to 0 and see what is the extreme point, namely what is the p-value for which the value is most probable. So we are taking the derivative of this, and this is the derivative of ln. Again, this is the same, and we are equaling it to 0, and this need to go. So we are solving for p. You can see this solution, and we get the value for p, which is what this is the value for p, 0.6, the most probable value for p given the distribution, the Bernoulli distribution, and this observed data. Of course, for any other observed data, we can have different values for the most probable b, the b that maximize the likelihood. Okay, so the likelihood is our probability distribution, and we use the observed data to build the function, and we take the log of this, and we take the derivative to find the extreme value, which will give us the value for the parameter which maximize the likelihood based on the observed data. Okay, so for different observed data, we will get different results. So we saw how we use the maximum likelihood estimation with using log likelihood function to get the better or more convenient function to take the derivative of, and now we took the derivative and got the result. So the MLE for P, the probability of success is P equals 0.6 in this specific example with this specific observed data. Thank you very much. This was on maximum likelihood estimation, MLE. If there are any corrections, please correct me, and that's is it.